Welcome to this video for your SolarWinds Platform Self-Hosted Architecture, Deployment, and Network Discovery. We will begin with an introduction to the SolarWinds Platform, starting with an overview of the SolarWinds Observability Self-Hosted, what it is and why it matters. Next, we'll explore the SolarWinds Platform architecture, examining how it integrates with our products, including SolarWinds Observability Self-Hosted, previously known as Hybrid Cloud Observability, and SolarWinds Observability SaaS, formerly known as SolarWinds Observability. We will also discuss Platform Connect, its purpose, and how it enhances functionality. Then we will cover the requirements for deploying SolarWinds Observability Self-Hosted, including key components and best practices. Finally, we'll dive into the network discovery process, explaining what it is, how it works, and guiding you through a demo of discovering network devices and adding them for monitoring. Let's look at the SolarWinds platform that runs the SolarWinds Observability Self-Hosted, the system, and the different parts and features. The SolarWinds platform is a versatile solution designed to support on-premises, hybrid, and cloud environments. It consists of two main components that cater to different deployment needs. SolarWinds Platform Self-Hosted, the primary focus of this training, is a next-generation platform built upon the foundation of the Orion platform, retaining core functionalities like discovery, mapping, alerts, reports, centralized data, and access control. It supports key modules such as NPM, SAM, and the SolarWinds Observability Self-Hosted solution. With significant improvements over Orion, it enhances visibility and monitoring across IT environments. SolarWinds Observability Self-Hosted integrates the strengths of existing SolarWinds modules, addressing customer feedback while introducing exclusive features. It enables monitoring across on-premises and cloud environment and provides a comprehensive view of IT infrastructure. Unlike traditional module-based installations, this solution simplifies monitoring by offering end-to-end visibility without requiring multiple installations. Organizations using older Orion platform versions should upgrade to the SolarWinds Platform Self-Hosted for improved performance, security, and access to new features such as SD-WAN monitoring for Meraki, Alert Stack for efficient alert management. Upgrading does not require an immediate transition to SolarWinds Observability Self-Hosted, but customers can activate a 30-day free trial directly from the license management page. SolarWinds Platform SaaS, a cloud-native fully managed SaaS offering designed for DevOps, full-stack monitoring, and AIOps-driven insights. It powers the SolarWinds Observability SaaS, providing features such as application performance monitoring, digital experience monitoring, and database monitoring. Platform Connect bridges the gap between the self-hosted and the SaaS platform. For organizations operating in hybrid environments, Platform Connect links SolarWinds Observability Self-Hosted and SolarWinds Observability SaaS offering. It has unified monitoring. It can import network devices and entity from self-hosted to the SaaS platform for centralized visibility. And it has advanced AI-driven alerts. You can leverage AI ops and machine learning from SaaS to enhance anomaly-based alerting in the self-hosted platform, reducing noise and improving alert accuracy. Expanding functionality with integrated modules, your SolarWinds Platform Self-Hosted continues to support and integrate with additional solutions including service management for your SolarWinds Service Desk. We also have your database management, which is your database performance analyzer, and IT security products such as patch management, policy report writing, security observability via Security Events Manager, and Access Rights Manager. Looking ahead, while the current platform offers comprehensive monitoring, the future of the SolarWinds platform remains open to innovation and expansion. Stay tuned for what's next. Now that we have a good understanding of the SolarWinds platform and components, let's take a look at the Platform Connect feature and benefits. Platform Connect is a feature within the SolarWinds Observability Self-Hosted, designed to integrate your self-hosted installation with your SolarWinds Platform SaaS. By installing the SolarWinds Observability SaaS agent, Platform Connect establishes a link between the two SolarWinds platform environments. If you utilize both the SolarWinds Observability Self-Hosted and your SolarWinds Observability SaaS, this feature allows you to forward self-hosted network devices data to the SaaS platform, making it accessible into the cloud. Currently, network and server node metrics along with flow data are supported for monitoring in SolarWinds Observability SaaS, with additional metrics and device types planned for future updates. AI-driven alerts and Platform Connect. The Platform Connect also enables AI ops-driven anomaly detection in your SolarWinds Observability self-hosted environment, allowing you to configure advanced anomaly-based alerts, a significant enhancement to alerting capabilities. Importantly, this integration does not migrate your monitoring environments to the cloud, nor does it require a SolarWinds Observability SaaS purchase to enable anomaly-based alerting. The only requirement is an API token which can be generated from a SolarWinds Observability SaaS account, evaluation, and trial. Platform Connect is a cloud-based infrastructure monitoring, and anomaly-based alerts are all part of the SolarWinds Observability Self-Hosted when running on the SolarWinds platform Self-Hosted. When signing up and creating SolarWinds Observability SaaS account, you receive a 30-day fully functional evaluation, allowing you to explore SaaS capabilities just as you would with any other SolarWinds products. To successfully set up Platform Connect, a few key requirements must be met. First, your SolarWinds Observability Self-Hosted server must have internet access, and you need to create a SolarWinds Observability SaaS user account. This enables you to display on-premises network and infrastructure data in the SolarWinds Observability SaaS web console. More importantly, the cloud platform powering SolarWinds Observability SaaS hosts the AI Ops and machine learning engine that supports anomaly-based alerting on your SolarWinds Observability Self-Hosted. As demonstrated in the upcoming demo, you will need to log into the SolarWinds Observability SaaS to generate an API token, which is required for Platform Connect configuration. Creating a SolarWinds Observability SaaS account allows access to the AI Ops engine on the SolarWinds Platform SaaS. However, this does not mean you are committing to SolarWinds Observability SaaS. Upon account creation, you receive a fully functional 30-day evaluation, allowing you to explore its capabilities. You can either create a new SolarWinds Observability SaaS account during the Platform Connect setup process or use an existing account to retrieve an API token. Additionally, you must be running the SolarWinds Observability Self-Hosted Advanced license to utilize this feature. Now let's walk through the Platform Connect setup process. In the SolarWinds Observability SaaS platform, after you've logged in with your SolarWinds Observability SaaS account, all you need to do is go to Settings and then look for API tokens. Here you can create an API token. So once you have created an API token, all API tokens will be listed here. Now you can use that API token to connect the SolarWinds Observability Self-Hosted Platform to the SolarWinds Observability SaaS platform via Platform Connect. In your SolarWinds Observability Self-Hosted Platform, navigate to Settings, All Settings, and scroll down and look for Platform Connect. Click on Add Edit Platform Connector. Here you can see the settings for the Platform Connect. At the top, you have the option to edit or view the API token. Or you can log into your cloud account if you need a new token or wish to access SolarWinds Observability SaaS. You have options on how you wish to use Platform Connect. First, you can choose whether or not you wish to send your alerting metrics to the AI Ops engine on the SaaS platform to use machine learning and anomaly detection in alerts. You can also choose whether or not to utilize network infrastructure observability to monitor network and infrastructure metrics in the SolarWinds Observability SaaS web console. Furthermore, you can also define which nodes using groups, as well as whether you want to monitor just network node metrics or flows and any other metrics such as virtualization or server nodes. Uninstall agent will uninstall the SolarWinds Observability SaaS agent, which is used in the function of Platform Connect. It's important to understand that this is not the same as the SolarWinds Platform agent that we will be discussing in other videos. In the interest of time, we will not be going through a live demonstration of SQL. However, we will discuss the installation requirements and standard recommendations for installing SolarWinds Platform Self-Hosted with SolarWinds Observability Self-Hosted and the required SQL databases. The SolarWinds Platform Self-Hosted must be installed on a Windows Server 2016, 2019, or 2022. It is compatible with FIPS compliant, STIG compliant, and Device Guard compliant operating systems. During the installation, the configuration wizard creates 3 databases, regardless of whether you are using the Essentials or Advanced license for SolarWinds Observability Self-Hosted. First, you have the primary SolarWinds Platform database. And then you have the log database, which can be hosted on the same SQL instance as the primary database, or a separate SQL server depending on the traffic volume. And then you have also your flow storage database. Typically resides on the same SQL instance as the primary database. For database deployments, we recommend using SQL Standard or SQL Enterprise for large-scale environments. SQL Express is only suitable for small evaluation setups. SolarWinds Observability Self-Hosted requires SQL Server 2016 Service Pack 1 or later. And then the storage and RAID recommendations. To achieve the best database I/O performance for SolarWinds products, we strongly recommend using RAID 1+0. They are both mirrored and striped arrays. This configuration provides an optimal balance of speed and redundancy. Please avoid RAID 5 or any dual parity RAID levels. These configurations negatively impact I/O performance, even with SSDs or high-performance disks. RAID 0 is an option, but it lacks redundancy, making RAID 1+0 the preferred choice. Now, there's a full list of system requirements, and you need to refer to this particular link. Now, there's a full list of system requirements, and if you want to know more about the system requirements, kindly refer to this official documentation. SolarWinds Observability Self-Hosted is compatible with most default SQL settings during installation. Adjustments are typically unnecessary unless your environment has specific requirements. If you are uncertain whether modifying a SQL setting will impact your database, please reach out to support for guidance. Now, installing SQL. The authentication support for SolarWinds Observability Self-Hosted, it fully supports Windows authentication for SQL databases, including both local and domain accounts. Active Directory can be on-premises, local, or Azure AD when deploying in Azure. Security considerations. Windows authentication encrypts usernames and password credentials, but does not encrypt the data. So to encrypt database data, enable SSL encryption. Also, for your SQL account requirements, the SQL authentication is supported but requires mixed mode authentication with strong passwords. New database user must be on a DB creator role. For existing databases, the DB owner role is sufficient, and the user account must be assigned to the security admin server role. Now, using the SA account. The built-in SA account naturally meets these requirements. It's feasible. We recommend using it for SQL authentication to ensure proper permissions for database setup. After installing SQL, we recommend a few additional requirements to optimize performance for your SolarWinds Observability self-hosted databases. If possible, SQL Management Studio is a useful tool for implementing these changes. If your organization has database administrators, these recommendations are worth discussing with them. While some are general SQL best practices and may already be in place, it's always good to verify. You need to separate SQL data and log files. For optimal performance, store SQL data files and log files on separate logical drives using separate physical disks is even better. This is why the accepted SQL best practice. Ideally, the setup should be in place before writing to the database. However, if data is already being written, you can stop the SQL service or detach the database. Make the necessary change and then restart it. So implementing this configuration is well worth the effort as it significantly improves I/O performance. You need to enable auto growth and configure file growth to either XMB or 10% of the database size, whichever best suits your database needs. However, do not restrict the maximum file size. Set it to unlimited. The storage requirements for SolarWinds will fluctuate over time based on factors such as amount of historical data retained, and if a maximum file size is enforced and reached, the database will be unable to write new data properly. Allocating more RAM improves performance, but ensures that sufficient memory remains available for the operating system. SQL Server will consume as much as possible all the memory that it can get into. So it is essential to manage allocation effectively. You need to use a memory calculator to determine the appropriate RAM allocation and configure the reservation in SQL Server Management Studio. Now, there are detailed recommendations for SQL Server configuration best practices. This particular information is found in this particular web page for your SQL Server configuration best practices. There are a few more reminders about installing SolarWinds Observability Self-Hosted. Do not install SolarWinds Platform Self-Hosted on the same server as the database. The installer will stop you from doing so and assumes you know what you're doing. Hopefully, it is apparent why you shouldn't do this. Both the platform and the database needs a good chunk of resources and are likely too much for a server in production. So just don't do it. It won't end well. And you cannot install SolarWinds Platform Self-Hosted on a domain controller or an MS SharePoint or an MS Exchange server. In fact, the installer will stop upon detecting these on the installation server. And then finally, SolarWinds Platform Self-Hosted installs very well to defaults. There's no need to change them unless you have some other considerations or requirements, and you can do so. Now, we will not be doing a live installation for this particular video of the SolarWinds Observability Self-Hosted, but there is an installation walkthrough available also on our customer portal, and if you wish to view the process on your own. Now let's talk about finding and monitoring entities after you've installed the SolarWinds Platform Self-Hosted. Now, the first thing that you will see after the installation of the SolarWinds Observability Self-Hosted Platform is the Discovery Central. So this is what the Discovery Central would look like. Now, the first step that you need to assume after you've installed the SolarWinds platform is for you to start discovering the entities that you would like to be added for monitoring. Now, this is an example of the Network Sonar wizard when you're planning to discover entities to be added for monitoring. The first step in network discovery is to define the segment of your network to perform the discovery. Now, in this example, we're going to add devices using a small range of IPs in our environment. If this is the first time that you're running this discovery process, we strongly recommend starting with a small group of nodes to get your feet wet on this particular process. As recommended here in the wizard, try to discover not more than 512 devices at a time. Other than specifying network ranges to perform the discovery, we can also specify network using, or we can also specify networks using CIDR notation or via seed router. Now, this particular method here, IP ranges, is meant for IPv4 devices, while this IP address section here is for both IPv4 and IPv6 IP addresses. There is also an option to discover your Active Directory and discover the computers that you would like to be added for monitoring. Say, for example, I am going to add my credentials here. Okay, and then let's go ahead and test the credentials. Click on Next, and then choose the OUs that you would like to be discovered during network discovery. So in this regard, we have 36 computers, and we have 2 domain controllers and 4 PM groups included in my Active Directory domain controller. The VM host monitoring tab allows you to add your virtual infrastructure entities like Hyper-V host, VMware ESX host, Nutanix clusters, and a lot more for monitoring. This method employs the VMware API or the Nutanix API or WMI for your Hyper-Vs for their respective types of virtual infrastructure entities. Through these polling methods, we can capture information about the guest virtual machines hosted on these entities without adding them as managed nodes. Even if we skip this part, basic monitoring of these entities can still be carried out as standalone servers considered as nodes through ICMP, SNMP, and WMI polling. Next would be agents. So the agent tab would be seen here, and if this is the first time you're going through this wizard following an installation, you're probably not using agent monitoring other than on the platform server itself. However, if you have an agent in the past, or if you use agent monitoring for your nodes from previous installations, you may be able to discover those agents here. Now, you can also use agent monitoring for your nodes in the future. This would be useful to capture any changes to those agent monitored with the network discovery job, so that you can also run the network discovery on a regular basis. In this particular tab, this is where you get to provide your connection profiles through network devices that you would like to be configured for network device configuration management. So this is where you could add those SSH and Telnet credentials so that you can communicate with SSH-capable devices. Now, SolarWinds support SNMP version 1, version 2C, and version 3, and will auto-detect what is supported on each device during the discovery process. Make sure that the most frequently used credentials are on the top of the list to make the discovery a little faster. SNMP version 3 credentials can be managed through the Manage SNMP version 3 credentials library in the All Settings menu. Now, for any Windows devices detected, we use WMI to collect basic server health information, as SNMP is not configured by default on Windows devices. WMI requires credentials with admin privileges to access and gather data for this information. Credentials can be managed through the Manage Windows Credentials library in the Settings menu, similar with your SNMP uh, version 3 credentials. And you can use this in network discoveries or access them when adding nodes. Although WMI polling represents a more significant resource load than SNMP polling for the same information, we cannot control this. It is a characteristic of WMI. Also, while certain challenges exist with WMI polling, we still recommend it as a default agentless polling method for Windows servers because not all accessible info gets surfaced with SNMP, and SNMP agents to be installed and configured to each Windows machine that you want to monitor. While agent polling can help with many of the WMI challenges, it does mean managing an extra piece of software in the process. If there are devices in the network segment that do not respond to WMI and SNMP, but responds to ICMP, you can choose to monitor them using ICMP as the polling method, and you will be able to capture the availability of these devices and their response times, and also measure the packet loss information, but no more than that. Preferred polling method simply designates which polling method to try first. For example, if SNMP is selected, the polling method will be attempted first. If the device, such as a Windows server, does not respond to SNMP call, it will attempt WMI polling. So if you're discovering a segment with more Windows servers and you are prepared to monitor all of them with WMI, it would make sense to set this to WMI. Conversely, if the segment is expected to have more SNMP-enabled devices, it would make sense to set this to SNMP. Now, once the supported protocol is identified on a node, SolarWinds can automatically set up everything for which the assigned poller can poll on the node, and you will choose what to monitor on every discovered node by configuring the defined monitoring settings. You may choose to manually define the monitoring settings on every discovered node by choosing this option. For your first time, though, through network discovery, and especially when you're adding a small group of nodes, we recommend the manual option to see the process, starting from discovering the nodes to defining what we want to monitor on them and choosing which nodes to import for monitoring. Uh, this part helps you familiarize yourself with the discovery feature and what the SolarWinds Observability Self-Hosted can monitor. Most of the time, people leave these at defaults, and we recommend them to be at defaults, especially for the first time. Though feel free to give your discovery a more user-friendly name if you wish. Now, discovery scheduling enables discoveries to be scheduled on a regular interval. Okay, you can routinely scan the network for new devices and changes to those devices you are already monitoring so that your monitoring stays current. Clicking Discover will run the discovery depending on how many nodes you find and how quickly they respond and network speeds that you are utilizing. So this process could be quick or it can take a while. Now, if you chose the option to manually define what to monitor earlier, you will be presented with the discovered devices when the discovery completes, so you can choose which ones to add for monitoring and what to monitor on the nodes. Everything discovered, including devices, interfaces, volumes, applications, configurations, and etc., is listed for choosing what to monitor. Now, here in the interfaces window, you will see uplinks for trunks and typically critical interfaces such as switch links to router can have a widespread effect if they go down. You also have access, endpoint links and interfaces of a less critical status. And you will see if they are operationally up in use on the network and is in an up status, And you have operationally down, interfaces turned on and in use, but currently in a down status. And you also have administratively shut down, turned off through administrative configurations. This section is similar to what you saw in the interfaces, where you can select the ports to import for monitoring. SolarWinds Observability Self-Hosted offers volume and basic hardware monitoring, and recommended types are selected but can be customizable. Now, you will be given a select number of applications that SolarWinds Observability Self-Hosted specially monitors, uh, namely App Insight for Active Directory, App Insight for IIS, App Insight for Exchange, and App Insight for MS SQL, and Windows scheduled tasks. Some of the common applications that would be monitored by your SolarWinds Observability Self-Hosted. In the Configurations tab, it includes monitoring network device configuration on network devices and assigning configuration profiles for IIS, software inventory, and hardware inventory to server nodes for server configuration monitoring. Here you can see the import preview. You can preview your selections before importing them for monitoring. If there are nodes that you do not wish to monitor and should be muted in subsequent discoveries, you may select them and click ignore to put them into the discovery ignore list. So say for example, I am going to ignore this particular Windows machine, click on ignore, and that would be included in my ignore list. Once you click on import, the selected elements will be imported to the SolarWinds Observability Self-Hosted. The time it takes to import can vary and largely depends on the number of elements. A summary will appear and indicate when the import is complete. And after the import, the actual data may take a few minutes to show in the web console, and you are looking at a period to allow for several polls before you have historical data in the database. Many terms will be clarified in a series of videos that we have for you in the customer portal. However, here are some of the key ones to get started with. First, the web console. As we just saw, this is the primary feature of the SolarWinds platform self-hosted and is the user interface where product information is viewed and managed. The web console is highly customizable and feature-rich. Most configurations and management of the SolarWinds Observability self-hosted features are performed through the web console. A view is an individual web page within the web console, such as the Home Summary view or the Top 10 view. A resource, or also called a widget, are snap-in components displayed within a view and show detailed information about the objects in the environment, such as interfaces with high bandwidth utilization or active alerts. Entities are individual nodes, interfaces, links, or other monitored elements that are pulled and viewed in the SolarWinds Observability Self-Hosted. Entities have unique records in the database with unique statistics and may be pulled independently from each other. Now we are here in the summary page of your web console, and presumably after discovering all of the elements that you would like to be monitored by your SolarWinds Observability Self-Hosted. Now, there are pop-ups that show how to edit the views, and this would be a later video when you're trying to configure views for the web console. Menus are activated by a mouse hover, and the show drop-down menu on my dashboards and on the alerts and activity and reports and settings are available. So when you go to My Dashboards and then Home, um, this is what we term as core, or what we refer to as core or platform features, meaning they are part of the SolarWinds platform regardless of the modules installed or activated. Now, even with the SolarWinds Observability Self-Hosted, the respective modules like NPM SAM, NTA, or NCM, or if you are on the SolarWinds Observability Self-Hosted Essentials or the Advanced, they are still used to refer to the capabilities of those modules here in My Dashboards. Now, there are legacy names that we haven't renamed yet um, to indicate features instead of the legacy names, but we will be working on updating these menus that you see here in the My Dashboards dropdown. New views and widgets to observe what you want and how you want are also available, and this is a perfect example of a new view. When we go to Network Device Configuration, click on Config Summary, you can use the new user interface, which is similar to what a modern dashboard would look like. Now, everything here in the dashboard indicates um, key performance indicators, list of nodes, some changes that have happened on device configurations, and charts that would give you an overall idea what's happening with devices within your environment being monitored for config changes. Let's go back to the summary page of the web console. So you can simply click on the SolarWinds logo on the top left portion of the screen, and it will redirect you to the summary page of the web console. So menu bars contain views, and you have the home summary view, and each box with data within the view is a resource or a widget. So this is a resource or a widget. Customizing the page allows you to add additional widgets or resources to your view, and you can show the data that you want to see and where you want to see it. So you can move these around and resize also the column heights or add more widgets to be seen here in the web console. The All Nodes widget, the levels are customizable. Node statuses are color-coded for easy identification. Of course, green is normal, yellow is warning, and red is critical, and maroon with no icon at the center indicates that the node is down. Gray is unknown, although we don't have an example of gray here. And we will discuss what contributes to the node status shown here in a different video. You can hover your mouse over to any particular node and see the details about the node and possibly why the node status may show as green, yellow, or red, or maroon. So when we click and drill into a node, it will show you the node details. So here you can see the node details, and in the left navigation pane, you can also go to the interfaces to show you which active interfaces are being monitored, and you can also use this for troubleshooting down interfaces. In the Node Details view, you have a Management widget. In the Management widget, you have the Edit Node link here, where you can edit the node properties, such as polling, the credentials that you need to use, or you can also change the polling engine assignment for this particular node if you have an additional polling engine that you would like to use, and much more with regards to node polling. You could also change the node thresholds that you would like to represent warning and critical respectively exclusively for this particular node. It can be done on individual node basis, and you can also use several nodes, and you can edit the node properties all at the same time. You also have the list resources section. Okay, this is where you can open the resources for monitoring for this particular node. So it will show up which resources you would like to monitor. And if you want to monitor any of them, simply put a check mark on the tick box right beside the name of the resource for monitoring. As you can see, these resources that you would like to monitor are currently checked. And this is here, and this is where you can also leverage which status and response time to check first, whether you want ICMP or SNMP. Still in the management section of this particular Atran node, we have the Poll Now button. Now, it doesn't mean that it's real-time polling. When you click on Poll Now, it will still have to respect the standard polling interval that is meant for polling for this particular node. And what it does is it leverages this particular node to be first among the rest of the nodes that are being polled by the platform. So you are prioritizing this particular node to be polled first from a list of nodes that you are currently monitoring. There is also a delete node. Okay, it allows you to delete this particular node from being monitored along with all its interfaces and associated elements from being monitored by the platform. We also have the performance analyzer. Now, this particular tab allows you to perform real-time polling for this particular node. It uses a different service in conducting real-time polling compared to standard polling intervals or the standard polling jobs. You also have the maintenance mode, which allows you to set this particular node in maintenance. And you can also schedule the maintenance mode for this particular node so that it will stop collecting data from this node, and it will also pause the alerts associated with node downtime or node availability. Now, there is a subview here for the vital stats view. Okay. And the vital stats, this is what deemed to be vital for the node functionality. And you should be able to see some menus regarding response time and packet loss, or CPU load and memory utilization. Now, um, since this is a demonstration, I only have network latency and packet loss available here in the vital stats view for the this particular Atran device. Going back to the interface subview for this particular demo, here we can see the interface details, and you have the receive and transmit. With regards to charts, you may not have historical data. As to why, it hasn't stored much information yet after your initial installation of the platform. You have to wait for several polling intervals to happen in order for historical data to be stored in the SolarWinds primary database. And that's when the time that your charts and your graphs would be available for view in the platform. Now, going back to the home menu here in my dashboards drop down, you have the summary, the groups, the environment. The environment is or it pertains to a feature called AppStack, and we will talk about what AppStack is as a feature of the platform. We also have the same link that you saw a while ago, performance analysis for a real-time polling for certain metrics that you can um, observe out of monitored nodes. Also have event summary. We also have a link for the TWAC community, custom summary, training, maps, anomalies, quality of experience, and virtualization. So these are the tabs that you see here in my dashboards and in the home section. Now, the drop down for settings is split into all settings, network discovery, manage nodes, manage dashboards, and my deployment. Let's go to the all settings window. Here you have different menus available for main settings and administration. And here you have um, different sections like getting started, node and group management, alerts and reports, product specific settings, thresholds and polling, credentials, user accounts, views. Uh, if you want to customize the navigation and look, the details with regards to your platform, and lastly, the Platform Connect is also available here in the um, All Settings window. Let's head over to My Deployment. In this particular section, there are several areas to manage your deployment in this particular dashboard. So you have servers. This is where you can manage your high availability if you're using that in your environment. You also have the Deployment Health tab. This area gives health check results and recommendations either directly within the software or other items in the environment, such as database issues. You have also the Updates tab, and this is where you will find the uh, planning tools for your platform. And you can also install additional products or update your products, including hot fixes and service packs. And you can also perform centralized updates to your scaling engines, such as additional polling engines. And this is a separate topic that would be discussed in greater detail in our scaling the SolarWinds Observability Self-Hosted Platform video. Lastly, we have the diagnostics window, which collects diagnostics information that you can then forward to support for advanced troubleshooting. Thank you for watching this video for your SolarWinds platform self-hosted architecture deployment and network discovery. If you want to watch more videos on demand, they are available in our customer portal, and you can watch them at your own pace and leisure.